Every day, millions of people open ChatGPT, type a question, and seconds later, an answer appears. But almost nobody stops to ask, what actually happens between those two moments? Because the instant you hit enter, your prompt begins a journey through one of the most advanced technological systems humanity has ever built. A journey through global internet infrastructure, massive AI data centers, billions of calculations, and artificial intelligence models operating at unimaginable scale. What feels like a simple conversation is actually the result of one of the most complex engineering systems ever created. This is what actually happens when you use ChatGPT. When you look at an application like ChatGPT, the simplicity of the interface creates an illusion. Because the response feels almost instantaneous, our brains assume this level of intelligence is happening directly on our device, as if the AI somehow lives inside your phone or laptop. But your device is merely an entry point to the cloud. The moment your finger releases the Enter key, your prompt begins a massive digital journey. Your text is broken into tiny packets of data, converted into pulses of light, and launched through your local Wi-Fi router into the global internet infrastructure. Within milliseconds, your request travels through regional internet exchange points, fiber-optic networks, and undersea communication cables stretching across continents and oceans, traveling at extraordinary speed. Your message races through one of the largest communication systems humanity has ever built. But this is only transit. The actual AI inference process has not even begun yet. Eventually, your request arrives at its destination, a massive enterprise AI data center. From the outside, these facilities often look strangely ordinary. Windowless buildings, minimal branding, heavy security. But inside, thousands of advanced computer systems operate continuously. Day and night, rows of high-performance GPU clusters, specialized AI processors, cooling systems, network switches, and industrial-scale infrastructure working together in perfect synchronization. The moment your request enters the cloud environment, automated systems begin processing it immediately. API gateways validate the request. Load balancers distribute computational demand. Authentication systems verify permissions. Available compute resources are assigned in real time, and within milliseconds, your prompt arrives at the AI inference cluster. But here's the extraordinary part. Despite arriving at one of the most intelligent systems humanity has ever created, the machine still cannot actually read a single word you wrote. To understand artificial intelligence, we first have to abandon the human idea of language. Because computers do not process language the way humans do. They process mathematics. Before your prompt can enter the neural network, it passes through a system called a tokenizer. The tokenizer breaks your sentence into smaller fragments called tokens. Sometimes a token is a full word. Sometimes it is only part of a word, or punctuation, or even fragments of meaning. For example, a simple sentence like, "Explain quantum computing," might be divided into multiple computational fragments before the AI ever begins processing it. Because artificial intelligence does not interpret language the way humans do, it decomposes language into mathematical structures. Once the sentence is fragmented into tokens, each token is converted into a unique numerical identifier. To the AI, your prompt is no longer a question. It is now a sequence of numbers, a mathematical representation of language itself. Those numbers are then mapped into an incredibly complex system called an embedding space. You can think of this as a massive mathematical map, where ideas with similar meanings are positioned closer together. Not by spelling, not by grammar, but by statistical relationship. In this strange digital landscape, concepts like king, queen, power, government, and leadership may all exist near one another mathematically. Because the AI has learned relationships between ideas through enormous amounts of training data. Your original thought, something created in the human mind, has now been transformed into high-dimensional mathematical geometry. And now, for the first time, your prompt is finally ready to enter the heart of the machine, the neural network transformer. This is where things become truly extraordinary. At the center of ChatGPT is a massive neural network, a computational architecture inspired loosely by the human brain, but operating entirely through mathematics. Modern AI models contain billions, sometimes trillions, of adjustable mathematical weights and connections. Tiny computational relationships trained to recognize patterns across human language. When your prompt enters the system, the AI does not browse the internet searching for answers. During standard inference, the model generates responses from a frozen snapshot of its training. Instead, it begins predicting what token is most likely to come next, one token at a time, then another and another, at extraordinary speed. This prediction process is powered by one of the most important breakthroughs in modern artificial intelligence, the transformer architecture. Transformers allow the model to analyze relationships between words, concepts, and context simultaneously. Through mechanisms called attention and positional encoding, the model can evaluate relationships across its entire context window at once, not just one sentence, but entire conversational structures simultaneously. This is why ChatGPT can explain ideas, summarize documents, write software code, answer follow-up questions, and maintain surprisingly natural conversations. The AI is constantly calculating probabilities, evaluating billions of possible language pathways in real time, searching for the response most likely to sound useful, accurate, and human. But something even more fascinating is happening underneath the surface. As the model generates each token, it continuously reevaluates the entire context of the conversation. Every new word changes the probability landscape. Every sentence reshapes the prediction process. The AI is not thinking like a human mind. It has no self-awareness, no emotions, no consciousness. But through enormous computational scale, it creates the illusion of intelligence with astonishing realism. And sometimes, that illusion becomes so convincing, people forget they are interacting with a prediction engine built entirely from mathematics. So why does ChatGPT feel so natural? Why do millions of people feel like they are talking to something intelligent instead of a machine? The answer begins with training. Because before ChatGPT ever responded to a single user, it was exposed to enormous amounts of human language. Books, websites, research papers, documentation, conversations, billions of examples of how humans communicate. Over time, the model began identifying hidden statistical patterns inside human communication itself. Patterns of logic, patterns of storytelling, patterns of emotion, patterns of persuasion, patterns of humor, patterns of curiosity. The AI learned how humans explain ideas, argue with one another, teach concepts, write stories, and structure conversations. Not through understanding, but through mathematical association at enormous scale. That is why ChatGPT can sound intelligent, empathetic, persuasive, confident, and surprisingly human, because it has analyzed extraordinary amounts of human expression. And sometimes, the illusion becomes so convincing, people begin assigning human qualities to the machine itself. But despite appearances, ChatGPT does not think, it does not feel, it does not understand meaning the way humans do. It predicts language extremely well. But that exact reliance on probability introduces a dangerous side effect. Because ChatGPT generates responses based on probability, it can sometimes produce information that sounds convincing, but is completely incorrect. This phenomenon is known as hallucination. The AI may invent facts, statistics, historical events, citations, or even entirely fictional sources. Not because it wants to deceive you, but because its objective is different from human reasoning. The system is optimized to generate the most statistically plausible response, not necessarily the most truthful one. This is one of the greatest challenges in modern artificial intelligence, because systems capable of sounding highly intelligent can still generate completely inaccurate information with extraordinary confidence. And as AI becomes more integrated into education, business, medicine, research, and everyday life, the consequences of misinformation become far more serious, which is why many experts argue that AI should assist human thinking, not replace it. Behind every ChatGPT response exists an enormous physical infrastructure, massive GPU clusters, industrial cooling systems, power distribution networks, fiber backbone connections, cloud orchestration platforms, and data centers consuming extraordinary amounts of electricity every second. Training modern AI models can require thousands of advanced GPUs, months of continuous computation, and billions of dollars in infrastructure investment. Some AI facilities draw hundreds of megawatts of power, enough to sustain a city of hundreds of thousands of people. Because artificial intelligence is no longer just software, it is industrial-scale computation, one of the largest technological infrastructures humanity has ever constructed. Every time you use ChatGPT, you're interacting with an invisible system built from mathematics, engineering, cloud computing, and artificial intelligence operating at planetary scale. What feels like a simple conversation is actually billions of calculations unfolding in real time across global infrastructure networks. And this technology is evolving faster than almost anything humanity has ever witnessed. The age of artificial intelligence has already begun, and we are only seeing the beginning. To continue exploring this frontier, subscribe to ENITECH, where deep tech is simplified through cinematic storytelling.